Alright, starting back up from where we were finishing the formatting, just a couple last things. The IRR, internal rate of return, and net present value. These are different methods of seeing is the project worth doing or not. And the ultimate question, invest or not, and why. You can actually do an if or statement. Otherwise, this is really just a net present value IRR question, when you should and when you shouldn't invest. We'll get to that later. First, we should start answering the actual problem. Now at this point, there's only a few things that we really need left. You type in your depreciable base amount, and after that, you're pretty much golden. You look through it one last time, make sure you've got everything, didn't miss any important aspects. But if you haven't, then it's time to start the problem. Alright. Can minimize your internet window. You might need it in case you need to look up different answers for what is this or what is that. But again, I'm going to go through those with you, and you shouldn't need to if you follow along. Starting out, loan amount is going to be the acquisition price times the loan to value ratio. Loan to value ratio tells you how much you're taking out as far as a loan goes to the value of the house. The value of the house, you're taking it as the acquisition price. Gives you $900,000. Mortgage interest rate is there. You input that manually. You set this up as a problem. Equals payment. And I tab. I'm going to do FX. Select the rate. Number of payments for the loan. It's going to be loan term, which is 30 years times 12 for 12 months in a year. So 360 total payments. And you can see that number over here. The present value, simple enough, is the loan amount. And you don't need to, but you can enter your future value as 0. So, enter. Don't worry about the type, by the way. Those of you who are looking at it, not a big deal for this, not important. It can be in other problems and situations, but again, not relevant for this problem. So, next problem, depreciable base. How much can actually be depreciated off the cost of the house? And the number that we're given is 85%. We're going to use that number. We're going to multiply it times the acquisition price. It's going to give us an idea how much can we actually take off from the price of the house. Just so you know, this payment here, $49,500, that is a monthly payment. Just keep that in mind. Loan term, you can even do that. Set it so that it's years, in case you don't know or you forget. It can be helpful sometimes. So, PGI, it's basically present possible gross income. Excuse me. And you're going to use the number of units times the rent times 12, because you're doing the PGI for the year. And keep in mind, you're going to want to keep these absolute values, these absolute references, because you don't want to have it be dragged and change something. It's not particularly a big deal because you're not going to be dragging that at all, but just in case. Now you're going to reference the previous year's value here, that's cell B33, you're going to multiply that times the rent growth, which we have here as 3%. Now this value is important to keep as an absolute reference, because now we're going to drag this over and we're going to get the next value, and that's going to go and tell us this. Key thing to keep in mind, the present growth is going to be 1 plus. You want to make sure that you have that in there. And make sure that you have it times the whole value. As you can see, Excel caught my error and I selected its solution. That's one nice thing to keep in mind. I was able to show you a little bit. Now, less vacancy equals this times the vacancy rate, 11%. And this is another cell. You want to make sure that's an absolute reference, because we can drag this over and it fills those in automatically for us. One nice thing about Excel, it has that function. And then the EGI, which is the gross income minus the PGI minus the vacancy. Can bring that over. And estimated gross income. Alright, just to make things clear, PGI, potential gross income, EGI, effective gross income. Again, PGI, potential gross income, what you could make, minus the vacancy that you expect, the effective gross income, what you can expect to actually earn. Now, total operating expenses, TOE, you can take equals the fixed expenses, which are expected to be 12% or $12,000, and you can enter that. And because of how you set it up, you can drag it down and it'll enter your variable and reserves. Then you have this wonderful ability to also enter this value times a growth rate of 3% fixed expense growth. Now, again, make sure that's done as a 1 plus the fixed expense growth. And I'm going to show you something. It's nice to just drag this down in a similar fashion to how you drag down the other choice, the fixed to variable to reserves. But now you have to go and take into account that this should be set as an absolute reference. And you should do that in all of these, not just one. And then just drag it over. And you get your values. And then total operating expenses is going to be a sum of these numbers. And you can go ahead, take that, drag it. And then net operating income is going to be your effective gross income minus your total operating expenses. Debt service you can figure out by taking the monthly loan payment, making that an absolute value, and multiplying that times 12. It's going to be your debt service each year. And this before tax cash flow. Alright, and I want to just make a point. This payment should be divided by 12. That was a mistake. If I take this out once, you can see 49,500. Things look really strange, ridiculous. Why are we not making any money at all? This is a horrible investment. And if we just take a little bit of time, divide the interest rate by 12, all of a sudden, oh wow, magical. Everything seems to work out beautifully. That's just the name of this game. You can make mistakes sometimes. You gotta be careful. You can drag this over. Again, this is just a simple sum formula, a simple addition of these two values. Remember, if you keep your payment positive, you're going to need to go and do a subtraction of these two values. But you can set this equal to your NOI, drag it over, add your reserves, reserves amount, reserves for replacement, 10,000. We make that value absolute once, equals previous value times, let's see, the reserves growth is 3%. And so we're going to do 1 plus 3%. Make that cell absolute. Add in your parentheses, hit enter, and drag. Now, you can also, of course, use the reserves amount here, but I have a tendency to go right back up to the top. It's kind of a personal opinion, not necessarily a necessity, but just something I do. And being as there is no need for it, you don't necessarily need the zeros, but I like to keep things somewhat consistent, so I do have them in this one. Now, interest, I'm going to use a nice little formula. Cumulative interest payment, interest paid between two periods. So, I'm going to go to the formula box, going to go to enter our rate, which is a monthly interest rate. Divide that by 12. Don't want to hit enter because obviously there are more parts to that than just the interest rate. We're going to do the loan term times the number of years, which is, or excuse me, the loan term, number of payment periods times 12, number of years times 12. The present value is the loan amount, and then our start period, if we're going to do the year 1, is going to be 0, end period 12, and OK. Of course, gotta make sure we do things right, and that sometimes means scrolling to the bottom. Type. Now this is going to just enter the type as 0, which is going to mean that the payment's paid at the beginning of the month versus the end of the month. Now,